Together, an apple and a banana cost 95 cents. 3 apples and 2 bananas cost $2.50. Find the cost for a single apple and for a single banana. Since they're asking us to figure out how much an apple costs and how much a banana costs, those are going to be our variables x and y. So let's let the cost of an apple be x, and let's let the cost of a banana be y. Now, because we have 2 variables in this problem, we have to write a system of equations with 2 equations to solve this. The first equation is going to come from the first sentence. Together, an apple and a banana cost 95 cents. So if we take the cost of an apple, x, and add to that the cost of a banana, y, we know that together that's going to be 95 cents, or 0.95 in dollars. The other sentence gives us another scenario, which will give us another equation. 3 apples and 2 bananas cost $2.50. Well, 3 apples is going to be 3x, and then 2 bananas is going to be 2y. So 3x plus 2y has to be $2.50, because that's the total cost of 3 apples and 2 bananas. So now we have our system of equations, and we can solve this either using substitution or elimination. I'm going to use substitution here because the first equation has an x and a y without a leading coefficient that we'd have to divide by. So we can avoid having to divide and possibly make these decimals even worse. Now we can solve either for x or y, but I want to look at a little trick. If we're trying to figure out which variable to isolate when we're making a substitution, the math ends up being a little bit easier if the variable that we isolate is the one that has the smaller coefficient in the other equation. So if we look at the other equation, we've got 3x and we've got 2y. The y is the one that has the smaller coefficient, so what we want to do is we want to isolate the y in the other equation first. It doesn't actually make a difference, but this is going to help us avoid a negative sign, which we ended up having in the last problem. It makes the math just a little bit easier. And the fewer negatives we have, the fewer places there are to make mistakes. So we want to start by isolating y, and we do that by subtracting x from both sides. This gives us y equals 0.95 minus x. And we're going to take this and we're going to substitute it into the other equation. So wherever we see a y in the other equation, we're going to replace it with 0.95 minus x. So we have 3 times x plus 2 times y, but we said that y was equal to 0.95 minus x, so we'll substitute that in here. And that equals 2.50. Now we have an equation that only has x in it, so we can solve for x. We're going to start by distributing that 2. So we have 3x plus 2 times 0.95 is 1.90. And then minus 2 times x is 2x, and that's equal to 250. We can combine the like terms on the left. 3x minus 2x is just x, so x plus 190 equals 250. And if we want to get x alone, we subtract 190 from both sides, 1.90. And that leaves us with x on the left, and 250 minus 190 ends up being 0.60, which is effectively 60 cents. Now, to figure out the value of y, we need to substitute this into an equation that has x and y, but we already have one where the y is isolated. So we're going to plug x in here. So we have y equals 0.95 minus x, but in this case, x is 0.60. And when we perform the subtraction, 0.95 minus 0.60 is 0.35. We go back to the let statements. The cost of an apple was x, but that's 0.60, and that's in dollars. So $0.60 or 60 cents. A banana cost y, and y is $0.35 or 35 cents. So when they ask us for the cost of an apple and the cost of a banana, we can say an apple costs $0.60 or 60 cents, and a banana costs $0.35 or 35 cents. Either way. We could write these answers with cent symbols instead of dollar symbols and decimals, but because everything was given to us in dollars, it's nicer to write our answers in dollars as well.